Hello everyone and welcome. I'm Professor Diwa. In this video, I'll be going over solving rational equations. Our objectives are to solve equations containing rational equations. Alright, so let's get started. For example number 1, we need to solve the rational equation 3x over 4 minus x over 2 equals 1 over 2. When working with rational equations, we have to keep in mind the domain. For each fraction in the equation, we could see that the denominators have a constant value. We have 4, 2, and 2. This means that we could use any value of x, and the denominator will not result in 0. So the domain would be all real numbers. Next, we need to get rid of the fractions by multiplying each fraction by the LCD, which is 4. So we have 4 times 3x over 4 minus 4 times x over 2 equals 4 times 1 over 2. Next, we simplify. 4 times 3x over 4. The 4's cancel out and we get 3x. Next, we have 4 times x over 2. 4 divided by 2 is 2, and then we have 2 times x, which is 2x. Next, we have 4 times 1/2, which is 2. So the result is 3x minus 2x equals 2. Next, we combine like terms with the 3x and the minus 2. This is just x. So our final result is x equals 2. Next, we write our final answer in set notation. I have a set of curly brackets and 2 on the inside. Moving on to part B, we have 3 over x minus x plus 21 over 3x equals 5 over 3. First, we find the domain for this rational equation. You can see for the first denominator, we have x. The second denominator, we have 3x. And then the last denominator, we have a constant 3. For the first two fractions, we cannot use the value of 0 because that results in 0 in the denominator. So this means that this rational equation is undefined at x equals 0. Next, we get rid of all the fractions by multiplying each fraction by the LCD of 3x. So we have 3x times 3 over x minus 3x times x plus 21 over 3x equals 3x times 5 over 3. Next, we simplify. We have 3x times 3 over x. The x's cancel out. We have 3 times 3, which is 9. Next, we have 3x times x plus 21 over 3x. The 3x's will cancel out, and we have x plus 21. Next, we have 3x times 5 over 3. The 3's will cancel out. We have x times 5, which is 5x. The result is 9 minus parentheses x plus 21 equals 5x. Next, we distribute the negative inside the parentheses to the x and the plus 21, and then we also bring down the other terms. The result is 9 minus x minus 21 equals 5x. From here, we could combine 9 and minus 21 to get negative 12, and then we bring down the other terms. The result is negative x minus 12 equals 5x. Next, we get rid of the minus x on the left-hand side by adding x to both sides of the equation. The result is negative 12 equals 6x. Next, we get rid of the 6 in front of the x by dividing both sides by 6. We have negative 12 divided by 6 equals 6x divided by 6. Next, we simplify. Negative 12 divided by 6 is negative 2. 6x divided by 6 is x. So the final result is negative 2 equals x, or you could write it as x equals negative 2. Our final answer is written in set notation, so I have a set of curly brackets and negative 2 on the inside. Next, we have a practice problem for you to solve. For part A, we have 5x over 6 plus 1 over 2 equals x over 3. For part B, we have 5 over x minus 3x plus 6 over 2x equals 7 over 2. Alright, so go ahead and pause the video, solve each problem, and then check back with the video to see the solutions. Okay, so let's get started with part A. For part A, the domain is all real numbers because we have a constant value in the denominator for all of the fractions. The LCD is 6, so we multiply all the fractions by 6. We get 6 times 5x over 6 plus 6 times 1/2 equals 6 times x over 3. Next, we simplify. 6 times 5x over 6, the 6's cancel out, and then we get 5x. 6 times 1/2 is 3, and then 6 times x over 3. 6 divided by 3 is 2, and then we have 2 times x, which is 2x. So the result is 5x plus 3 equals 2x. Next, we solve for x by getting rid of the 2x. We subtract 2x from both sides, and we subtract 3 from both sides of the equation. The result is 3x equals -3. From here, we get rid of 3 by dividing both sides by 3. We get 3x divided by 3 equals -3 divided by 3. Simplifying the left-hand side, 3x divided by 3 is x, and on the right-hand side, -3 divided by 3 is -1. The final result is x equals -1. We write our final answer in set notation, so I have a set of curly brackets and a -1 on the inside. For part B, the rational equation is undefined at x equals 0, and the LCD is 2x. So we multiply each fraction by 2x. We get 2x times 5 over x minus 2x times 3x plus 6 over 2x equals 2x times 7 over 2. Next, we simplify. 2x times 5 over x, the x's cancel out, and then we have 2 times 5, which is 10. Next, we have 2x times 3x plus 6 over 2x. The 2x's cancel out, and we're left with 3x plus 6. Next, we have 2x times 7 over 2. The 2's cancel out. We have x times 7, which is 7x. The result is 10 minus parentheses 3x plus 6 equals 7x. Next, we distribute the negative inside the parentheses to the 3x and the plus 6, and we bring down all the other terms. The result is 10 minus 3x minus 6 equals 7x. From here, we combine like terms with the 10 and the minus 6, which is positive 4, and then we bring down all the other terms. We have -3x plus 4 equals 7x. Next, we get rid of the minus 3x by adding 3x to both sides. We get 4 equals 10x. From here, we get rid of the 10 by dividing both sides by 10. We get 4 divided by 10 equals 10x divided by 10. Next, we simplify. 4 over 10 reduces to 2 over 5. 10x divided by 10 is just x. The result is x equals 2 over 5. Our final answer, written in set notation, we have a set of curly brackets, and on the inside we write 2 over 5. Next, we have example number 2, solve. We have the rational equation x plus 6 over x minus 2 equals 2 times the parentheses x plus 2 over x minus 2. First, we need to find the domain. If we look at each denominator, you can see that we have x minus 2 for both fractions. The only value of x that we cannot use for this rational equation is 2. If we plug in 2 in for x, we get 2 minus 2, which results in 0 in the denominator. So the rational equation is undefined at x equals 2. Next, we get rid of the fractions by multiplying both sides of the equation by the LCD, x minus 2. We get parentheses x minus 2 times x plus 6 over x minus 2 equals 2 times the parentheses x plus 2 over x minus 2 times the parentheses x minus 2. Next, we simplify. On the left-hand side, we could cancel out the x minus 2's. We're left with x plus 6. On the right-hand side, we cancel out the x minus 2's. We're left with 2 times the parentheses x plus 2. So the result is x plus 6 equals 2 times the parentheses x plus 2. From here, we distribute the 2 inside the parentheses to the x and the plus 2, and then we bring down all the other terms. The result is x plus 6 equals 2x plus 4. Next, I did 2 steps at once. I subtracted x from both sides of the equation, and I subtracted 4 from both sides of the equation. The result is 2 equals x, or you could write this as x equals 2. Because our value for x resulted in the x value that makes the rational equation undefined, this means that we have no solution for this rational equation. So I wrote a circle with the diagonal line going through it to indicate that there's no solution. Next, we have a practice problem for you to solve. We have x plus 5 over x minus 3 equals 2 times parentheses x plus 1 over x minus 3. Okay, so go ahead and pause the video, take your time solving this rational equation, and then check back with the video to see the solutions. Okay, so let's go over the solutions. First, we take a look at the domain for this rational equation. The only value of x that we cannot use is 3. So the rational equation is undefined at x equals 3. Next, we get rid of the fractions by multiplying the LCD, which is x minus 3. We get parentheses x minus 3 times x plus 5 over x minus 3 equals 2 times the parentheses x plus 1 over x minus 3 times parentheses x minus 3. Next, we simplify. On the left-hand side, the x minus 3's cancel out, and we're left with x plus 5. On the right-hand side, the x minus 3's cancel out, and we're left with 2 times the parentheses x plus 1. The result is x plus 5 equals 2 times the parentheses x plus 1. From here, we distribute the 2 inside the parentheses to the x and the plus 1, and we bring down all the other terms. The result is x plus 5 equals 2x plus 2. Next, I did 2 steps at once. I subtract x from both sides, and I subtract 2 from both sides. The result is 3 equals x, or you could write this as x equals 3. Because the rational function is undefined at x equals 3, this means that we have no solution. So for my final answer, I wrote a set of curly brackets with nothing inside. Next, we have example number 3, solve. We have the rational equation 2x over 2x minus 1 plus 1 over x equals 1 over 2x minus 1. First, we need to find the domain. We just take the denominators from each fraction and set them equal to 0. This gives us 2x minus 1 equals 0 and x equals 0. Solving 2x minus 1 equals 0 for x, we add 1 to both sides of the equation. The result is 2x equals 1. From here, we just divide both sides by 2. The result is x equals 1/2. So the rational function is undefined at x equals 1/2 and 0. Next, we get rid of all the fractions by multiplying each term by the LCD, x times the parentheses 2x minus 1. We get x times parentheses 2x minus 1 times 2x over 2x minus 1 plus x times parentheses 2x minus 1 times 1 over x equals 1 over 2x minus 1 times x times parentheses 2x minus 1. Next, we simplify. For the first term, we have the 2x minus 1's will cancel out, and we have x times 2x, which is 2x squared. For the middle term, we cancel out the x's. We get 2x minus 1 times 1, which is just 2x minus 1. For the very last term, we have that the 2x minus 1's cancel out, and then we have 1 times x, which is x. The result is 2x squared plus 2x minus 1 equals x. From here, we're going to set the equation equal to 0 by subtracting x from both sides. The result is 2x squared plus x minus 1 equals 0. Next, we factor the trinomial 2x squared plus x minus 1. We get parentheses 2x minus 1 times parentheses x plus 1 equals 0. Next, we use the zero factor property. We take each factor and set it equal to 0. We get 2x minus 1 equals 0, and we also get x plus 1 equals 0. Solving the first equation, we add 1 to both sides of the equation. We get 2x equals 1. Next, we divide both sides by 2. The result is x equals 1/2. Next, we solve the second equation for x. We just subtract 1 from both sides. We get x is equal to -1. For this rational equation, we cannot use x equals 1/2 because it's not part of the domain. So our only solution is -1. We write our final answer in set notation, so we have curly brackets, and on the inside we have -1. Next, we have a practice problem. Solve. We have the rational equation 5x over 5x minus 1 plus 1 over x equals 1 over 5x minus 1. Alright, so go ahead and pause the video, take your time solving this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. To find the domain, we take the denominators from each fraction and set them equal to 0. We get 5x minus 1 equals 0 and x equals 0. Solving the first equation for x, we add 1 to both sides of the equation. The result is 5x equals 1. Next, we divide both sides by 5. The result is x equals 1 over 5. So this rational equation is undefined at x equals 1 over 5 and 0. Next, we get rid of all the fractions by multiplying each term by the LCD x times the parentheses 5x minus 1. We get x times parentheses 5x minus 1 times 5x over 5x minus 1 plus x times parentheses 5x minus 1 times 1 over x equals 1 over 5x minus 1 times x times parentheses 5x minus 1. From here we simplify. For the first term we cancel out the 5x minus 1's and we get x times 5x, which is 5x squared. For the middle term we cancel out the x's. We have 5x minus 1 times 1, which is just 5x minus 1. For the last term we cancel out the 5x minus 1's and we have 1 times x, which is just x. So the result is 5x squared plus 5x minus 1 equals x. From here we set the equation equal to 0 by subtracting x from both sides of the equation. The result is 5x squared plus 4x minus 1 equals 0. Next we factor the 5x squared plus 4x minus 1. The result is parentheses 5x minus 1 times parentheses x plus 1 equals 0. Next we use the zero factor property. We get 5x minus 1 equals 0 and x plus 1 equals 0. Solving the first equation for x, we add 1 to both sides of the equation. The result is 5x equals 1. Next we divide both sides by 5. The result is x equals 1 over 5. Solving the second equation for x, we subtract 1 from both sides. The result is x equals -1. Now we only have one solution because the rational equation is undefined at x equals 1 over 5. So our final answer is written in set notation. We have a set of curly brackets and -1 on the inside. In example number 4, solve. We have the rational equation 2x over x minus 3 plus 6 minus 2x over x squared minus 9 equals x over x plus 3. First we need to factor the denominator of the middle fraction. We factor the x squared minus 9 as a difference of squares. So after factoring and bringing down all the terms, we get 2x over x minus 3 plus 6 minus 2x over parentheses x minus 3 times parentheses x plus 3 equals x over x plus 3. Next we need to find the domain of this rational equation. We just take each denominator and set it equal to 0. So I have x minus 3 equals 0 and x plus 3 equals 0. Solving the first equation for x, we just add 3 to both sides. The result is x equals 3. Solving the second equation for x, we just subtract 3 from both sides. We get x is equal to -3. So this rational equation is undefined at the x values of 3 and -3. Next, we get rid of all the fractions by multiplying each term by the LCD, which is parentheses x minus 3 times parentheses x plus 3. We have parentheses x minus 3 times parentheses x plus 3 times 2x over x minus 3 plus parentheses x minus 3 times parentheses x plus 3 times 6 minus 2x over parentheses x minus 3 times parentheses x plus 3 equals x over x plus 3 times parentheses x minus 3 times parentheses x plus 3. Next, we simplify. Starting with the first term, we cancel out the x minus 3's. We have parentheses x plus 3 times 2x, which is 2x times parentheses x plus 3. Next, we simplify the middle term. We have that the x minus 3's and the x plus 3's cancel out. We get 6 minus 2x. For the last term, the x plus 3's cancel out. We have x times x minus 3, which is just x times parentheses x minus 3. The result is 2x times the parentheses x plus 3 plus 6 minus 2x equals x times parentheses x minus 3. Next, we distribute the 2x inside the parentheses to the x plus 3, and we distribute the x inside the parentheses to the x minus 3, as well as bring down the other terms. The result is 2x squared plus 6x plus 6 minus 2x equals x squared minus 3x. Next, we combine like terms on the left-hand side with the 6x and minus 2x, which is 4x, and we bring down the other terms. The result is 2x squared plus 4x plus 6 equals x squared minus 3x. Next, I subtracted x squared from both sides, and I added 3x to both sides. The result is x squared plus 7x plus 6 equals 0. Next, we factor the trinomial x squared plus 7x plus 6. The result is parentheses x plus 6 times parentheses x plus 1 equals 0. Next, we use the zero factor property. We get x plus 6 equals 0 and x plus 1 equals 0. Solving the first equation for x, we subtract 6 from both sides. The result is x equals negative 6. Next, we solve the second equation for x. We just subtract 1 from both sides. The result is x equals negative 1. From here, we can write our final answer in set notation. So I have a set of curly brackets, and on the inside I wrote negative 6 comma negative 1. Next, we have a practice problem. Solve the rational equation 2x over x minus 4 plus 10 minus 5x over x squared minus 16 equals x over x plus 4. Okay, so go ahead and pause the video, take your time solving this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. First, we factor the denominator x squared minus 16 as the difference of squares, and we bring down all the other terms. The result is 2x over x minus 4 plus 10 minus 5x over parentheses x minus 4 times parentheses x plus 4 equals x over x plus 4. Next, we find the domain, so we take each denominator and set it equal to 0. So I have x minus 4 equals 0 and x plus 4 equals 0. Solving the first equation for x, we just add 4 to both sides. The result is x equals 4. Solving the second equation for x, we subtract 4 from both sides. The result is x equals negative 4. So our rational equation is undefined at x equals 4 and negative 4. Next, we get rid of all the fractions by multiplying by the LCD, which is parentheses x minus 4 times parentheses x plus 4. So we get parentheses x minus 4 times parentheses x plus 4 times 2x over x minus 4 plus parentheses x minus 4 times parentheses x plus 4 times 10 minus 5x over parentheses x minus 4 times parentheses x plus 4 equals x over x plus 4 times parentheses x minus 4 times parentheses x plus 4. Next, we simplify. So for the first term, we cancel out the x minus 4's. We get x plus 4 times 2x, which is 2x times parentheses x plus 4. For the middle term, we cancel out both x minus 4 and x plus 4. We get 10 minus 5x. And for the last term, we cancel out the x plus 4s. So we have x times parentheses x minus 4. The result is 2x times parentheses x plus 4 plus 10 minus 5x equals x times parentheses x minus 4. From here, we distribute the 2x inside the parentheses to the x plus 4 and distribute the x inside the parentheses to the x minus 4, as well as bring down the other terms. The result is 2x squared plus 8x plus 10 minus 5x equals x squared minus 4x. Next, we simplify by combining like terms on the left-hand side. We can add together 8x minus 5x, which is 3x, and we could also bring down the other terms. The result is 2x squared plus 3x plus 10 equals x squared minus 4x. Next, we could do two steps at once. I subtracted x squared from both sides, and I added 4x to both sides. The result is x squared plus 7x plus 10 equals 0. From here, we factor the x squared plus 7x plus 10. We get parentheses x plus 2 times parentheses x plus 5 equals 0. Next, we use the zero factor property, and we get x plus 2 equals 0 and x plus 5 equals 0. Solving the first equation for x, we subtract 2 from both sides. The result is x equals negative 2. Solving the second equation for x, we subtract 5 from both sides. The result is x equals negative 5. Our final answer we write in set notation, so I have a set of curly brackets and negative 2 comma negative 5 on the inside. Next, we have example number 5. Solve the rational equation z over 2z squared plus 3z minus 2 minus 1 over 2z equals 3 over z squared plus 2z. First, we need to factor the denominators completely. We could factor the 2z squared plus 3z minus 2 using the star method, and we could factor a common factor of z from the z squared plus 2z. After factoring and bringing down all the terms, we get z over parentheses 2z minus 1 times parentheses z plus 2 minus 1 over 2z equals 3 over z times parentheses z plus 2. Next, we need to find the domain, so we set each denominator equal to 0. We get 2z minus 1 equals 0, z plus 2 equals 0, 2z equals 0, and z equals 0. Solving the first equation for z, we add 1 to both sides. The result is 2z equals 1. Next, we divide both sides by 2. The result is z equals 1/2. Next, we solve z plus 2 equals 0. We just subtract 2 from both sides. The result is z equals negative 2. Next, we solve 2z equals 0. We just divide both sides by 2, and we get z is equal to 0. So the rational equation is undefined at z equals 1/2, negative 2, and 0. Next, we get rid of all the fractions by multiplying each term by the LCD, 2z, parentheses 2z minus 1, times parentheses z plus 2. We get 2z times parentheses z minus 1 times parentheses z plus 2 times z over parentheses 2z minus 1 times parentheses z plus 2 minus 2z times parentheses 2z minus 1 times parentheses z plus 2 times 1 over 2z equals 3 over z times the parentheses z plus 2 times 2z times parentheses z minus 1 times parentheses z plus 2. Next, we simplify by canceling out our common factors. Starting with the first term, we could cancel the 2z minus 1s and the z plus 2s. We get 2z times z, which is 2z squared. Simplifying the second term, we could cancel the 2's and the z's. We get parentheses 2z minus 1 times parentheses z plus 2 times 1 is just parentheses 2z minus 1 times parentheses z plus 2. For the last term, we could cancel out the z's and the z plus 2. We get 3 times 2 times the parentheses 2z minus 1, which is just 6 times the parentheses 2z minus 1. The result is 2z squared minus parentheses 2z minus 1 times parentheses z plus 2 equals 6 times parentheses 2z minus 1. Next, we can multiply the two binomials 2z minus 1 and z plus 2 together. We could also distribute the 6 inside the parentheses to the 2z minus 1 and bring down all the other terms. We get 2z squared minus parentheses 2z squared plus 3z minus 2 equals 12z minus 6. Next, we distribute the negative inside the parentheses and we bring down all the other terms. The result is 2z squared minus 2z squared minus 3z plus 2 equals 12z minus 6. Next, we could combine like terms on the left-hand side. 2z squared minus 2z squared cancels out, and we're left with negative 3z plus 2 equals 12z minus 6. Next, I did two steps at once. I added 3z to both sides, and I added 6 to both sides. The result is 8 equals 15z. Next, we get rid of the 15 by dividing both sides by 15. We have 8 divided by 15 equals 15z over 15. The final result is z equals 8 over 15. We write our final answer in set notation using curly brackets and 8 over 15 on the inside. Next, we have a practice problem for you to solve. We have the rational equation 3z over 3z squared plus 7z minus 6 minus 1 over z equals 4 over 3z squared minus 2z. Alright, so go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. So we start by factoring each of the denominators. We get 3z over parentheses 3z minus 2 times parentheses z plus 3 minus 1 over z equals 4 over z times parentheses 3z minus 2. The rational equation is undefined at x equals 2 over 3, negative 3, and 0. Next, we get rid of the fractions by multiplying each term by the LCD, z times parentheses 3z minus 2 times parentheses z plus 3. We have z times parentheses 3z minus 2 times parentheses z plus 3 times 3z over parentheses 3z minus 2 times parentheses z plus 3 minus z times parentheses 3z minus 2 times parentheses z plus 3 times 1 over z equals 4 over z times parentheses 3z minus 2 times z times parentheses 3z minus 2 times parentheses z plus 3. Next, we could cancel out our common factors. For the first term, we cancel out the 3z minus 2's and the z plus 3's. We get z times 3z, which is 3z squared. For the middle term, we could cancel out the common factors of the z's. We get parentheses 3z minus 2 times parentheses z plus 3 times 1, which is just parentheses 3z minus 2 times parentheses z plus 3. For the last term, we could cancel out the z's and the 3z minus 2's. We get 4 times parentheses z plus 3. The result is 3z squared minus parentheses 3z minus 2 times parentheses z plus 3 equals 4 times parentheses z plus 3. Next, we can multiply the binomials in the middle. We can also distribute the 4 inside the parentheses to the z plus 3 and also bring down the rest of the terms. The result is 3z squared minus parentheses 3z squared plus 7z minus 6 equals 4z plus 12. Next, we could distribute the negative inside the parentheses and bring down the other terms. We get 3z squared minus 3z squared minus 7z plus 6 equals 4z plus 12. Next, we simplify the left-hand side. We have 3z squared minus 3z squared cancels out, and we're left with minus 7z plus 6 equals 4z plus 12. Next, we could do two steps at once. We can add 7z to both sides of the equation and subtract 12 from both sides. The result is negative 6 equals 11z. From here, we could divide both sides by 11. We get negative 6 divided by 11 equals 11z divided by 11. The final result is z equals negative 6 over 11. Next, we write our final answer in set notation, so I have a set of curly brackets and negative 6 over 11 on the inside. Alright, so we reached the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.